Hello, good morning, all of you. Today I'm going to take a lesson on mechanics. It is your first video on mechanics. What is mechanics? So, in mechanics, we deal with motion, motion of a body. We try to understand many terminology related to motion. For example, a speed, velocity, acceleration, force, these things, torque, momentum, these things we deal in motion. Okay, motion is subdivided into two parts, kinematics and dynamics. In kinematics we learn what is speed, what is this, what is that. We know only what is. Okay, but in dynamics we learn about why is it. For example, if a ball is moving, then I would ask what is the position of this ball, what is the speed of this ball, what is the acceleration of this ball. Okay, so uh, these things are asked in kinematics, but in dynamics we will ask why is it moving. So the cause behind motion we asked in dynamics. Okay, let's take an example. There is a ball here, a motionless ball. Okay, it is not moving. Now, what is the position of this ball? Could you tell me, please, what is the position of this ball? To specify the position of this ball, you need some other things, something nearby it. For example, if I make a tree, if there is a tree here, then now same question, what is the position of this ball? Now you would say there is some distance from the tree. The ball is at some distance from the tree. With more clarity you would say it is at some distance in some direction. Okay, for example, it is this direction is north, and this ball is at 5 meter from the tree, then you would say the ball is at 5 meter north. Okay, so you need something. Okay, this something is called reference point. This is your reference point. When I will ask you where do you live, what is the position of your home, then you would say I live where a famous church or temple nearby my house. It is at 200 meter. My house is 200 meter towards south from church. So this church is reference point. Okay, now in my textbook we will not draw a tree. It's like we will use frame of reference. Okay, we will use frame of reference to specify the position of any body. We will not always going to draw a tree or touch church anything. We will use frame of reference instead of tree. Okay, This is your frame of reference. Cartesian coordinate axis, x axis, g axis, y axis. Okay, this is your plane x y axis, where you are, where I am standing. You are sitting on the on your floor, on your chair. Your chair is in this plane, xy plane. Length, breadth, this xy represent length and breadth, and this g represent height of your space where you are. Okay, so this is your frame of reference, and the origin here is your reference point. We specify position of anything, we locate position of anything from origin. This is your reference point here. This whole things are frame of reference, and this is your reference point. And then I would say this ball is at 5 meter. So in this way we can locate the position of anything. Okay? Now how can we express this condition, this situation? The situation is a ball is at rest. This is a physical event, a situation, whatever you say. So this ball is at rest. I want to express this situation mathematically. Okay, how? Then I would say x is equal to 5 meter, and if I can also use direction north. So this is your equation. In this way you can represent your data, your uh, situation mathematically. Your physical, your natural situation phenomena can be described by equation, and here it is the equation of these things. Okay, this x is your position with respect to origin. This is your magnitude of distance, magnitude of position. Not distance, we can't say here distance, because distance is considered that what's the distance, what's the length you traveled. The length is traveled is called distance, and position where you are stay, where you are, this is your position, and distance is where, how much you covered. So it doesn't cover. Okay, I don't know this ball come from here to here, or someone directly put it here, we don't know. So this is your position. Now we want to express this data, we want to describe this data in graph, this situation in graph. Okay, this is your equation of motion. Now let's draw a graph here. As you can see here clearly that uh, at any time t, when you see this ball is at same place. Okay, so I will draw a graph between position and time. Okay, this is the fundamental graph. You can also draw velocity time graph, acceleration time graph, but the fundamental graph is position time graph. Here it is your position, this g axis represent position, and this axis x axis represent time. You can take any quantity, any physical quantity, velocity, time, acceleration, anything in these axes. Okay, in this frame of reference which physical quantity is used here? So position. Okay, in this position, this x axis represent position in this direction, this g axis represent position in vertical direction, and this y axis represent position in towards you. So this is our position, and in this situation I take x axis, I take time instead of x axis. Now I start to observe this ball. When I start, I take that time t is equal to 0. Okay, so at that time, this is 1 second, 2 second, 0, 1, 2, 3, 4, 5, 1 meter, 2 meter, 3, 4, 5 meter, 0. So at 0 second, this ball was at 5 meter. Okay, 1, 2, 3, 1, 2, 3, 4, 5. Okay, now after 1 second, again I see it doesn't move. It is also it is again at 5 meter. So 1 second, I travel 1 second, I move to 1 second in t axis, and the position is 5 meter. So I will move 5 meter in position axis, 1, 2, 3, 4, 5, from origin to 1 second in this direction, and 5 meter in vertical. Okay, so you will come here again after 1 second, here after 1 second, here. So you will, when you connect this all point, you will get a horizontal line. This is the graph between position and time. Okay, this is how you can represent your data graphically. Somebody get misconception that ball is along this line. uh, the at time 1 second the ball is here, after time at time 2 second ball comes here, at 3 second the ball comes here. No, it is not like this. Okay, this line is not a path of your ball. It is not your path of your ball. It just says, this graph says at which time your ball will be where. Okay, this graph shows the position of this ball, and here you can see clearly your ball is at 5 meter from origin. It is not moving. So don't get confused that this ball is moving along this path. At 5 1 2 3 4, at 4 second ball will come here. No, this is the position time graph. Okay, now let's take our next example. Okay, let's take next example. Now this time your ball is moving, okay, in this direction. Now how can we represent, how can we describe this situation mathematically? So this is your frame of reference, origin, it is at some point here, 5 meter for example. After a certain time this ball will come here. Okay, position will increase, and the distance covered by this ball is this much in this duration. So how can we describe this situation mathematically? So we can write position is equal to, position is not equal to a constant any integer, it is this position here, this time, this position depend upon time. Okay, initially uh, that position was not depend upon time. At any time you would see the ball is at the same place, but in this case at any time the ball will not be at the same place. So position is depend upon time. We can also uh, write it like position is a function of time, and it may be equal to 5t or 5t square or anything, but there will be a term, a variable t in right side. Okay, if this ball is moving uniformly, uniformly means ball covers same distance in same time. For example, in 1 second it comes 1 meter in this direction. Then again, if it is uniformly moving, if it is moving uniformly, then after again 1 second this will this ball will cover same distance. Okay, so if it is moving uniformly, then equation will be like this, 5t. Okay, so what is the, how can we express this situation mathematically? Okay, equation of motion. So we can say that the position is equal to 5t or 5t square, like this, 5 plus 6t, in this way. Okay, there must be some t variable in right side. Okay, and you can also say this position, now this position is a function of time. This position is a function of time, it depends upon time. Okay, for this situation, this ball is at already 5 meter from the origin, so I will write 5, and then after a certain time this ball comes here some distance. Okay, then I will write t, and it is multiplied by 2, 3, 4, it depends upon situation, how is it moving. Okay, so let's take a simple 2t. So how you can this is how you can represent your motion, your situation mathematically. Now let's draw a graph. Time, position. To draw a graph, we will plot a table. We will make table first. To plot graph, we will first we will make a table. Position, time. So now at t is equal to 0, this ball was at 5 meter. When you put t is equal to 0 here, you will get 5. Now at t is equal to 1, you will get 7. 2, you will get 9. Now use this data in your graph. This is 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, and so on. Now at t is equal to 0, the position of ball is 5, 1, 2, 3, 4, 5. So this is the 5, 0. Okay, coordinate of your point. At 1 second, ball is at 7 meter. 1, ball is at 7, 1, 2, 3, 4, 5, 6, 7. So this is the 7, 1. Okay, I did mistake here. I should write x coordinate first and then y coordinate. So this is your y coordinate, this is your x coordinate. okay, xy. So I should write 0 5 here. This is the rule how you can um, put your data, okay. Otherwise someone will write in their way, and someone will in another way, and there will be so confusion. So there is some rule here, there is a fixed rule, there is no any reason behind it. To get rid of confusion, we use this way. Okay, again I did 0 5, okay. First x axis, x coordinate, then y coordinate. Now at 1 second, 1 uh, 1 2 3 4 5 6 7, so here. Then after 1 second, 2 second, the ball is at 9 somewhere here. And now when you connect all these point, then you will get a graph, a line, okay. This line represent the motion of this ball, how is it moving. It doesn't mean that your ball is at here, at this time your ball is at here, no, it doesn't mean. This is the graph between position and time, okay. Ball will come here from the origin. You can say this is the graph of your position, okay. So that's it for today. You will observe that in both graph we get a straight line, okay. So when any body moves uniformly, they have a straight line, linear graph, okay. You can also say it has linear graph for uniform motion. If a body is moving uniformly, then we will have a linear graph, okay. But it is not, if it is not, then we will have a curve like this, in this way, in this way, in this, okay.